Hi. So to start off our foray into the way electronics works, I promised to give an introduction into electricity and how things work around the circuit. So I have some theoretical examples and then I'm going to turn them into practical examples. Now I have three examples of circuits. One is a basic series circuit with two resistors. Another name for this is a voltage divider. The second circuit, which I will show later, is a simple parallel circuit with both of these two 330 ohm and 220 ohm resistors in parallel with each other. And the third circuit is a mixture of both. So we would have two resistors in parallel, and that parallel combination will be in series with another resistor. And the whole time, this source will be at 5 volts. Okay. So right now we have voltage coming out of the battery and a current flows. Okay, this current has picked up 5 volts from the battery. It flows and it drops some of the current on this resistor here and the rest of the current on that resistor there. There is a certain protocol into using Ohm's law to do circuit analysis on circuits such as these. It's very straightforward. The first step is to first of all calculate the total circuit resistance. Now in series, it's as simple as adding both resistors together, and that will be your total circuit resistance. So in this case, it's 330 plus 220 equals 550 ohms in total. Okay, so that's the total circuit resistance. The second stage is to use Ohm's law to calculate the total circuit current. And Ohm's law, as you know, is V equals IR. We have the total circuit voltage, which is 5 volts. We have the total circuit resistance, which is 550 ohms. And we simply plug the values into the equation, rearrange for I, and we get a total circuit current of around about 0.01 amps. Now this is very important because that same current of 0.001 that same current of 0.01 amps is flowing into this resistor and into that resistor. So this current is carrying 5 volts and it's dropping some of it on that resistor and dropping the rest on that resistor. So we can use that to look at each resistor individually. So now that we have the total circuit current in series, the total circuit current never changes. The current never changes. So we can use Ohm's law to calculate the voltage dropped on the individual resistors. So V1 is resistor 1 and R1 is the resistance of resistor 1. V1 is the voltage dropped on resistor 1. So V equals IR, and for the 220 ohm resistor we should be getting a voltage dropped of 2, and by simple arithmetic over here we should be getting a voltage dropped of 3. Okay, and confirm Kirchhoff's second law. The total voltage is dropped in the circuit should be the total amount of voltage going into the circuit. So we will now test that using a real circuit. So here I have the series circuit with the 330 ohms and 220 ohms resistors in series. Over here I have a power supply module. Now this is connected to a 9-volt battery, so it's powered by a 9-volt battery. But 9 volts isn't coming out of this power supply module because there's a regulator in here. And this basically sets the voltage to either 5 volts or 3.3 volts, depending on where your connections are. So I set it up such that the vertical strip here, closest to the red line, is live at 5 volts. And the vertical strip closest to the blue line is at ground. And I've set my circuit such that I get power coming into the breadboard, and then series, and then I've got power coming out again. And that's the sideways view of how I've connected it all up. Very straightforward, very simple. So before we actually put power into this, let's confirm the resistances of our resistors using the multimeter which I have here. So it's an auto range multimeter. It was very inexpensive, about £20 off of Amazon. Link will be in the description if you're interested in buying one. Set it to measure ohms, and by convention I always like to put the red as, you know, live, and black as a ground. So connect it between there and there to measure its resistance, and it full ranges to just below 200. Okay, so that's 220 ohm resistor. Now there'll be some discrepancy simply for the fact that I've plugged it into a breadboard. So I'm not going to go into why there's a discrepancy and why it won't read exactly to 220 ohms, but electricity kind of does what it wants if you're not very, very careful. So there's a bit of a discrepancy there in measuring the resistance. Over here, I'd expect to read just below 300 because this is the 330 ohm resistor. Mm, 276 ohms, okay. That's a slightly bigger discrepancy, but not game breaking. All right, so let's set this multimeter to measure DC voltage because we have a DC power supply here, and let's turn it on. So power is now going from this pin all the way down the red strip, and this yellow solderless wire feeds off of that power and gives 5 volts into the breadboard on this side. 5 volts, some of it gets dropped along there, some of it gets dropped along there. By the time the current flows back into ground, they have no voltage ready to pick up more voltage at the power supply. So in our theory, we calculated that we should read about 2 volts there and 3 volts there. So let's see if that's the case. So connect the voltmeter in parallel, and we read 2 volts on the multimeter. That's very good. So connect them in parallel across the 300 ohm resistor, and we should read 3 volts. And so that's 2.99, that's basically 3. So 3 plus 2 is 5. So Kirchhoff's second law has been obeyed. 5 volts came in, 5 volts was dropped along the entirety of the circuit. Energy conservation.